Okay, everyone. Good evening, beautiful people. I hope you're doing great. So, without any further delay, let's jump into um, this presentation. It's the hello word to machine learning. And you already said, you know, these guys, Gary Kasparov and Anatoly Karpov, they were champions in 1980s, 1990s, early 2000. And most of the time, Kasparov was the one who won the game. So in MIT, they decided to have a project. Yeah, um, they tried to. There was a project in United States, and they invited Gary Kasparov to attend that experiment, we could say. And do you know the name of that project by any chance? Yeah, Rachel. Beautiful. Oops. That's exactly what Rachel said. The Deep Blue was the name of a project. And the beautiful part is, what days today? Everything is collapsing now. So, Rachel, yeah, I found you here. Bravo. And Ruslan as well. Yeah, the Ruslan Mak. Yeah, correct, Ruslan. The problem is they designed that, but it was not enough lines of code to compete with Gary Kasparov. Then they started using a strategy that they called it brute force attack. And if you ask me what brute force attack could be, let me just show you one simple thing. Locker 3 digits. There we go. Okay, so can you see this locker on your screen? If yes, please type 1, please. Okay, bravo. One of our friends said something. Anand said, even more amazing is alpha. I'm going to talk about that. Exactly. You're going to see that, Anand. Thanks for bringing that. So, guys, in 1996, they used a kind of simpler version of Deep Blue. And in 1997, they used a strategy called brute force attack. And I brought this lock picture for you to tell what brute force attack means. Um, Tell me if you have enough time. I'm not talking about if you're in rush. If you have enough time, what could be the possibility? What is the number of attempts that you can do to unlock this lock? Can anybody tell? Hmm. Maharshi. Okay. Okay. Thank you very much. Let's just get to Matthew. Where did you grab that 720? I very much like that because your answer is totally different from the others. How did you come up with that? It's not then. It's not then 720. Okay, exactly. Parsa said the correct answer, and Negin also, and Roslan. So I consider that. Can I have your attention now? Parsa, where are you? Oh, okay, I'm gonna write your name somewhere to add mark later parcel, but because I couldn't find it quickly. Yes, exactly. That is 10 times 10 times 10. And Mahyar said, so I'm going to just write it this way. Mahyar said, again, the correct thing. And the strategy that they used for the first time to improve is to guess all the possibilities of the movement, and they assigned weight based on that, so they could predict these are the possibilities. Based on those possibilities, there might be a move from the opponent, which in this case is Garry Kasparov. And finally, because the computation is not a big deal for a computer, they could predict millions of other possibilities, and then they decide the best weight for that. So combination of some algorithms, especially brute force attack. So just please remember the name brute force attack. Where I started learning about artificial intelligence exactly started from this picture. The time that they said on the news, these two guys are Garry Kasparov is attending to an event competing with Deep Blue. But the idea was then just focusing on artificial intelligence. Let me just go through the slide. I told you today we are going to write our hello world. And after learning about the difference between machine learning and artificial intelligence, we are going to start working on a practical question. And after that, we define what classifier is, and a simple recipe that we are going to work on it tomorrow. Hopefully tomorrow, that's my design, that we could finish the content in 2 or 2.5 hours. And then the rest of tomorrow, we are gonna dedicate time for whatchamacallit, for the assignment number 2. The best is, please read the assignment tonight. Try to see what you can grab. Especially today, we have the fundamental parts that help you to start the assignment. But after that, tomorrow we are gonna complete the package that we can start working on the assignment. And if you have any concern and question, you can ask. So tomorrow, in a kind of row-based groups, we are going to work on assignment. I want to make sure you're going to go to the reading week without any worried about the assignment, so you can just work on it and get the best result, okay? We already talked about the project Deep Blue versus Garry Kasparov. Still, we are talking about the era called artificial intelligence. The problem of artificial intelligence is this: early AI, or general purpose AI, they call it. They typically can solve one problem, right? They are excel in, for instance, playing chess. You cannot bring that to solve any other issue. And if you want to do that, you have to do everything all over again. Does that make sense? And that is not very much efficient. We need something that is what we desire. That's what we want, to write one program that can solve a number of problems without needing to write the code all over again. So you want computer, you want that program, that application learn by itself without hard coding all the details. Does that make sense? So if you want to remember one sentence is, general or early AI was excel in only one task, while machine learning's algorithms are there to solve several problems without any need to write the code again. If it is super clear, as Ali said, let's give me, yeah, high five, type 5. True, Ali. Bravo. Merci. Amazing. And let's go to the next part. As Anand said earlier, if I'm not mistaken, that friend was Anand, right? That we have AlphaGo. It was in 2017 that AlphaGo actually started. It was a kind of project that started learning from, and it was very dumb at the beginning. It took a while to catch the game, but after a week it started, I mean, just competing with the players that they participated, and finally it could beat the champion of the alpha game. That one was very fast. I mean, improvement. The beautiful part in AlphaGo, which happened in 2017, was compared to 1996 and 1997. It was not AI, it was machine learning. So you could just use the same algorithm instead of AlphaGo to play an Atari game without any need to change the whole scenario. Does that make sense? So you can just use the same algorithm. And it sounds too good to be true, but we are gonna learn in no time, in a few minutes, how that works. A brief definition of machine learning is the algorithms. These are the algorithms that learn from examples and experiences instead of relying on hard-coded rules. You may say, what does it mean, Reza? Why should we go that approach? And what are the differences between the classical way of solving problems, especially in developing environments, compared to AI machine learning? Do you have any idea, guys? Can you please step in and tell what are the differences between these two? Classical approach and what I'm explaining as machine learning. I very much like that, Lucas. Sometimes you share word of wisdom and I learn. Lucas. Who else? Okay, to the interest of time, I'm gonna just jump to, okay. Ali said, for classical approach, you know exactly what is happening at each step. Bravo. Oh, it's like paragraph 1, Lucas, paragraph 2, Ali. You can just look at it, guys. Those who, yeah, they complete each other. So if you don't mind, let me just go to the next slide. You see that in traditional way of programming, we have rules, and then we have data, and we expect to receive answers for them. You may say, what are you talking about? Let me just show you one thing. Please look at this one. very simple. Imagine that I say A is equal to 10 and then B is equal to 20, for example. So what are they? They are what we call them data, right? And then we say C is equal to A plus B. And then simply we say print what? C, huh? So in classical form, we have data, as you see. We have rules that we say is plus, and we expect to have the result. The thing is, mostly here, deterministic versus, that is awesome. We are going to talk about it next semester, the deterministic versus probabilistic. Or at the end of this semester, we just point a few things. But this is not always the case, guys, right? The thing is, in machine learning, we are going to provide answer. So if I want to tell you, it's just symbolic way. I'm going to say we have A as 10 and B as 20. And guess what? C is equal to 30. And we are not sure what the functionality that we have used, let's say X, between A and B that results into 30. So we have the input, we have the output, and we want to guess what happened between those input parameters that gave that 30 to us. That's a very simplified description of machine learning, but it's not far from the truth. In other words, in machine learning, we have answers not for one example. Imagine what if A is equal to 5 and B is equal to 10, then the C is 15, and we have that 15. So we have lots of inputs and outputs. We have lots of data and answers, input and outputs, and we want to understand what could be the rules. And the thing is, actually, we are not interested in knowing those rules by ourselves. We want to keep those rules and use them later. It's like a black box sometimes for us, right? Does that make sense? So instead of creating an algorithm to solve a problem, you create a framework to model the problem, letting the code learn as you or the model give feedback, increase its effectiveness. It is very nice, Anand. I very much like that explanation. Okay. So I summarize what I learned from your replies, and I say in traditional kind of programming, we have rules like plus, summation, whatever. We have inputs, data, and we are going to calculate the answers. If that part is completely clear, please type 1. Traditional. Lovely. In AI and machine learning, in machine learning specifically, we have the input A equal to 10, B equal to 20. We have the output C is equal to 30, for example, and we have lots of inputs, lots of outputs, lots of examples, and we want to understand what could be the rules that created that kind of relationship, right? So if that is clear as well, please type 2 this time. Bravo. So look at this one, and let's get back to the traditional way of programming. Imagine that you have 2 different fruits, and you want to write a program. Now, please pay attention to this part. I'm not saying write a machine learning algorithm, traditional program, to distinguish between apple and orange. Can you please tell me what are the functions that you are going to use, what are the things that you're going to consider as the attribute. Color, for example, not bravo, yes. Shape, color, and again, you are hungry, right? Taste. Shape, texture, weight, light diffusion. Peter. So let me just, those who didn't get any bonus so far, William, Peter, amazing. Let me just, Anand already had, so Nash, the one of the friends said at the beginning, not me. And which class are you in? I'm sorry. I don't know. I don't want to miss your bonus. Oh, I found you. I found you. Minat. Yeah. And Nash. Thank you, Nash. Great. So did I miss anyone for the Matthew? Bravo. Okay. So Peter, Ali already had one. Yeah. Huh. Anand. Beautiful. Okay. Nice. So as you said, let's just go to the next slide. You can have, for instance, some of these things like color, edges, shapes, texture, and even because I've chosen these two pictures because we have some orange colors, orange pixels in here. If I can just use the laser pointer, we have some orange colors here and some kind of shadow of red in this part. So the ratio could be another thing, right? Thank you very much, Anand. What I'm gonna do is that is me. I'm a kind of lazy in these things. And I write, yeah, control to read it at my convenience. So let's go to the next part together. But so now the question for you is it going to be general enough? What if we change a few things? You know, the real world is not as nice and neat like this one. Like we have this type of apple or that type of orange, or we just want to write a program that works for apple and oranges. You know, the pitfall is, what if the real world is actually messy? And if we change just one parameter, the whole regulations that we have written would be collapsed down and we have to write all the code all over again. Imagine that we change just color from the colory images into black and white, right? Or as Matthew said, maybe there are some apples that are not very much in good shape. Or if we just change them with two other fruits, right? Like grape and banana. So we cannot use the same set of colors, or we cannot use the same set of shape that we have designed for this one, right? We can say the features that we have, guys, if you if you could follow everything this till this moment, please type 1. Okay, so let's focus on this. If we have machine learning algorithms, we need to have some input data. The input data that we call, so basically the ML will try to figure out the best case scenario to find. Okay, we talk about this NS in no time. Yeah. Technically, you can consider machine learning as something like a function. The classical definition of function, that we have some inputs. It could be 1, 2, and then we have a label, right? So based on the features that we fit into the system, we expect to have the output to say if it is apple or orange. Does that make sense for everybody? So we have those features. And for this toy example, we are going to use some specific features, and we simplify it. Look at this one, and that is the most important thing that I want you to consider. We use one algorithm here, whatever that algorithm is. If you search, guys, we have lots of names like K nearest neighbors. Next session tomorrow, we're going to work on that. A binary classifier, random forest, gradient boosting, artificial neural nets. I'm not talking about convolutional neural nets, artificial neural nets, naive Bayes, and a lot more. This binary decision tree. So these are the names of the algorithms that we have in the middle, right, in this place. And when you use one of those algorithms, and we are going to dive deeper which one you are going to use for this or for the other, just know that the same algorithm could work in different, totally different problem, right? Yes, you see that linear regression, logistic regression. The problem of logistic regression, it's a classifier. Some people, because of regression name, think that it's a regression algorithm, which is not. A linear decision, yes, naive Bayes, K nearest neighbors. Yeah, you said it. Enes, thank you very much. There are lots of gradient boosting, for short, it's used, boosting, random forest. Yeah, okay. So you see that we have all those algorithms, and you use it for apple and orange, and you can use the same algorithm for something like what? For just knowing one email is spam or not a spam. So you see, we have used machine learning in our daily life a lot. One of them is like when you open your Gmail, you see that there are some of them in your spam. And the thing is, nobody is going to check our email one by one, but a system checks that. Can you please tell me what other area you can name that we used without directly knowing that this is machine learning or deep learning or whatever? These kind of algorithms, anybody can tell. Spell check computer. That's a very good example. What else? Ali, that one can be done with normal programming too. Self-driving, that's the example of reinforcement. Good example. But Ali, I give you bonus because that is possible that we use and that's correct. Okay, if you don't mind, I'm gonna just consider a few, and we keep going because still we have some stuff to cover. Lucas, that's a very nice thing that you addressed. Raleigh, as well as what Raleigh said, and you, both of you, one of the things that we use is fraud detection. Do you remember that we said, what is machine learning? It's all about the algorithm can define the rules for us based on learning from samples and examples, right? If we consider that as a valid definition of machine learning, exactly when something is off the pattern that we normally use, it is going to do what? It's going to give an alarm saying that, hey, this transaction, Reza is normally in Toronto, but that transaction randomly is from Italy. It cannot make sense because Reza is in Toronto and did a transaction in the morning, and after 1 hour we had a transaction in, for instance, Milan. It's not possible, right? And yeah, I would love to give all to give appreciation to all people who participated, William, and facial recognition. Google makes us CAPTCHA to train the or something like that. Yes, emotion recognition. Anand, bravo, exactly. We have that one, and actually people started using that for those who have different abilities to help them. Yeah, for instance, based on just their facial emotion that they show, something happens for them, right? So awesome. The thing is, this is super important. Please pay attention, and you're gonna see why. Okay, guys, if you can hear me clearly, please type 1. Okay, this is a kind of strategy that guys use whenever you want to drag people's attention, bring people's attention. Okay, look at this one. The technique to write the classifier automatically. I repeat it again, and if you want to take a snapshot from this slide, you already have this slide. You're gonna see this pretty soon, somewhere. Okay, so the technique to write the classifier automatically is called supervised. We have labels, right? We have, for instance, the color, based on the color, based on the weight, based on the shape. We have those features, and we say these guys, these features are for Apple. So Apple supervise these features supervise us to find a label, Apple. Does that make sense? So that is why we call them supervised learning. And it happens automatically to find those patterns, right? So the technique to write those a little different. The mechanism that we write automatically an algorithm to bring those features to a label, we call it supervised learning. So Reza, do we have something which is not, there is no label for it? Yes. And that one, we called it clustering, not classification. And this is not the topic for this or next semester. Just know that we have unsupervised learning as well. We have other techniques like reinforcement, but a technique to write the classifier automatically is called supervised because features supervise us to a label. So technically, everybody, please just make sure that you're going to use something. Oops, I'm sorry. I'm happy that there is no answer. Please type import, whatchamacallit, sklearn, and run it. And you should get the correct answer to make sure. If you use Anaconda, maybe you need to install something here, or PyCharm or something, you need to install but I strongly recommend for this assignment to use Google Colab, right? Everything is already preset for us. And I think that I know that if I just work with something like, whatchamacallit, like the IDEs like Visual Studio Code or ChatGPT, PyCharm, it's not easy for us to switch to other environments, but try to, just diversify your choices in programming. It's a good place for trying that. So let me just tell you guys, based on the beginning of the session that we started a little bit late, we finish at 5. I promise that we finish sharp at 5. Can you please see this one? We have in our recipe for supervised learning, we have 3 phases. The first one is collecting data. The second one is training classifier. And the last one is make predictions. Well, technically, we want to use the algorithm that the result of the model that we created to do something. And that doing something in machine learning is predicting. We use mostly machine learning or deep learning algorithms to predict something in future, like weather. That is one of the examples that we can say. So weather forecasting is something that happens in future, Or as you have seen that when you start typing, even if it is on your phone or your text editor, it tries to predict what you want to say next. So these are all in future make predictions. Imagine that you head to an orchard and you want to collect some fruits. So you close our eyes and pick some fruits, and okay, I'm gonna just wait this one. The texture of the first is bumpy and it is 150 orange. The next one is bumpy as well, 170 orange, 140 smooth, 130 smooth, and your apple. Guys, you have all the right to say we have different variety of this. Imagine that this is kind of just toy example to understand what is happening in machine learning. So we call the first 2 columns, that you see features. And these features are going to supervise us to say if that fruit is orange or apple. Does that make sense? If it makes sense, please type 2. Lovely. Thank you very much. Look at this one. I write that features are 140, guys. I use the laser pointer. We say 140 smooth apple, 130 smooth apple. So these are the features like our inputs, and these are the outputs. 150 bumpy orange, 170 bumpy orange. Does that make sense? But the problem is scikit-learn doesn't like very much strings. So instead of saying smooth, we are going to say 1. And it doesn't know anything. We collect the data, Ali. We collect the data by ourselves. You pick the first fruit. It is, and we type it. We say that it is bumpy because we just write those values. Does that make sense, Ali? These are the things, the inputs, the features are what we collect. So the weight is something that we measure, and we say it is bumpy or it is something, right? That is why, and again, exactly, Peter, we say 140 smooth or 1, which is 0, which is apple, 130 smooth, which is 0, apple, and so on. Is it clear? Did I answer your question, Peter, as well? So we have just like you have one note and you write, okay, instead of saying smooth, we are going to use 1. Instead of saying apple, we are going to use 0. Huh? Okay, awesome. And now we want to create the training classifier. And the training classifier, among all the possible algorithms that already Anand was kind enough, or one of our friends who just told me about these kind of algorithms, we choose binary decision tree. And the reason for that is because binary decision tree is simple. It's like some nested if then else's. Does that make sense? So instead of having just complex algorithms like artificial neural nets, we use a simpler version of algorithm, which is decision tree, one of the easiest algorithm to deal with. And it is easy to understand what is happening because, for instance, in deep learning algorithms, it is not possible for us to easily grasp what is happening, right? For our brain is not easy to grasp. So we use that algorithm in the middle, right? Exactly. We use that algorithm, and later you can just switch with another algorithm to see if the performance would be higher or lower or what. And now it's the time for us to predict what is going to happen if I just use another thing. But let's just go and learn something. Look at this one. We have the in this line from scikit-learn import tree. And we create one object here, let's call it classifier, that we go to the tree, and then we say dot decision tree classifier. Technically, CLF or classifier is a box of rules that we want to use later to see if a new fruit that we pick is apple or orange. Wow. I repeat it once again. We are going to make one object, classifier CLF, that goes to the tree library, and then we pick one decision tree classifier. And we want to know if a fruit that we pick is apple or orange. Technically, we want to understand the relationship between these two guys, features and labels, and to see if the next fruit is apple or orange. If it is clear, please type 1. Okay. Do you think, just please tell me, do you think CLF, currently CLF, is an empty box or full box? Can you please tell me, is it an empty box or full box? Do you have any regulation inside it? Lovely. It shows that you follow everything very much. I'm proud of you guys. Awesome. Awesome. Yes, it is empty. But in the look at this one, we say that if we consider a classifier as a box of rules, then we can assume the learning algorithm that we are going to just see in a few seconds, or the procedure that creates those rules for us. And look at this one. Here we say, hey, dear classifier, dot fit, use this method to find relationship between features inputs and labels outputs. Now CLF in line number 5 is filled with those samples, and we can consider CLF now has regulations. So in number 5, CLF, is it empty or full? Excellent. In line number 5, we find patterns. Fit is find patterns between features and labels. So now it is full. And if we go to the next and last step, is we want to use our classifier to predict what is going to happen. So the last line is saying CLF.predict let's pick another fruit, 160 and 0. If we look at it, 160 is heavier, like these oranges, and it is bumpy. So we expect to have what? Orange as the output, right? Do you think the answer would be 0, apple, or 1? Please type your answer. 160 and 0 could be 0, apple, or 1, orange. Okay, don't worry. Don't worry. Look at this one. 160 and 0, 160 are between these two. I guess that it should be among these category, which are ones, which are oranges. Do you see that? If it was 110 or 135 and 1 smooth, then we expected to have apple. Does that make sense? Guys, do you see the relationship between... I'm sorry, I don't want just to rush and do not pay attention to... Guys, can you see this? 160 is something in this category. 160 and 160 and 0. Do you think that it is in this category? If yes, please type Y. If no, please type N. Okay, lovely. So those guys are, because this one is for this and this one is for this, right? And look at the other one. Let's just use another color. This one is, when it rains, it pours. This one is 1, and this one is this one. Okay, control. Does that make sense? So that is why 160 is close to the group of ones, which is oranges. If it is clear now, please type 1. Okay, tomorrow I will quickly just go through this and just look at this one. If I run the code, and I have all those lines, let me just show you. Control C. The best is to run them separately, but the intention is just running and showing you that everything works fine. Sorry to keep you more than what I expected. So if you see that, and I say predict this one, control, it's going to tell you that it is 1, but if I change it to something like 110, for example, and it is a smooth, it should be in the apple or 0 categories. Look at this one, it's going to give us zeros. So tomorrow, what I'm going to do, I quickly go through this. I promise that what we learned, you can just apply them to other problems without any need to change the algorithm. Imagine that you want to classify the cars, if they are sport cars or minivans, based on the horsepower and the number of seats. You can exactly use the same algorithm, right? If you want the assignment number 2, if you want to go for any outdoor activities, playing tennis, badminton, or anything in the open area. You can use the same thing, for instance, temperature, and if it is rain or not, something like that, right? So we can use exactly the same thing. And if you ask the question, what about the using pictures? Yes, we can use that, but mostly we use deep learning for this, the same principles in general. And we're going to answer some questions like, how does this work in the real world? How much training data do we need to have? And how is the tree created? and what makes features good features, actually. By saying that, my sincere apologies for keeping you 3 more minutes, well, technically 15, and have a wonderful day. You have enough knowledge for starting your quiz, but if you want to wait till tomorrow after having the labs, that's totally fine. Yeah, you have that time. Take care of yourself, guys. Have a wonderful one, and see you tomorrow. Ciao. Bye. Thank you very much. Bye, guys. Bye.